This whole discussion about managing risk naturally raises an important question for me, and probably for many listeners, about the concept of biosafety levels, BSLs. We hear about these in the news sometimes, especially when there are concerns about labs handling dangerous viruses or bacteria. What's the core idea behind this tiered system, and how does it actually translate into practice for someone working in a lab day to day?
That's a great question. The biosafety levels, BSLs, are essentially a standardized system of containment precautions. They're designed to protect the lab workers, the surrounding community, and the environment from potentially infectious agents. You can think of it like a series of security levels for labs, with each level matching the specific risk posed by the biological agents being handled there. The higher the risk, the more stringent the precautions.
Okay, so what does the first level look like?
Right, BSL-1 is the lowest level. It's really for work involving well-characterized agents that aren't known to consistently cause disease in healthy human adults. They present minimal potential hazard to people and the environment. Think about working with non-pathogenic strains of E. coli, or the kind of yeast used in baking or brewing, often found in teaching labs. The practices here are basically standard good microbiological practices.
Like basic lab hygiene.
Exactly. Regular hand washing, no eating, drinking, or smoking in the lab area, wearing basic PPE like lab coats and maybe gloves. Proper waste disposal and routine disinfection of surfaces are standard too. It's sort of like having very good hygiene practices in a careful kitchen environment.
Okay, that sounds pretty straightforward. What's the next step up, BSL-2?
BSL-2 is for labs working with agents that pose a moderate potential hazard. These are microbes that can cause human disease, maybe of varying severity, and the risk comes primarily from accidental ingestion or exposure through broken skin or mucous membranes like splashing into the eyes. Examples here might include things like Staphylococcus aureus, which causes staph infections, or certain Salmonella species. At BSL-2, you need enhanced lab practices.
What does enhanced mean here?
It means stricter adherence to SOPs. Mandatory use of PPE gloves, lab coats, eye protection, or face shields are usually required. Access to the lab is more limited. Crucially, BSL-2 labs must have specific equipment like Class 2 biosafety cabinets for any procedures that might generate infectious aerosols or splashes. They also need readily accessible equipment for decontamination, like an autoclave, to sterilize waste and used materials. It's a definite step up in containment from BSL-1, more like a specialized clinical diagnostic lab or a dedicated research space.
Right. And then BSL-3, that sounds serious.
It is. BSL-3 is applicable to facilities where work is done with indigenous or exotic agents that can cause serious or potentially lethal disease, especially through the inhalation route. This is where you start dealing with really significant pathogens. Examples include Mycobacterium tuberculosis, which causes TB, or the SARS-CoV-2 virus that caused the COVID-19 pandemic. Because the risk is higher, especially via aerosols, the biosafety measures become much more stringent. Well, lab practices are very strict. Access is highly restricted. Only authorized personnel who've had specific training can enter. All procedures involving infectious materials must be conducted within certified Class 2 or, in some cases, Class 3 biosafety cabinets. The lab itself has special engineering features, things like double-door entryways, sealed windows, specialized ventilation systems that ensure directional airflow. Airflows from clean areas to potentially contaminated areas, not the other way around, and use HEPA filters to clean exhausted air. Personnel often require respiratory protection, like fitted N95 respirators or PPRs. Decontamination protocols for waste, equipment, and even clothing are very rigorous. It's a highly controlled environment.
Wow. Okay, that leaves BSL-4. That must be the highest level.
That's correct. BSL-4 is the maximum containment level. It's reserved for working with dangerous and exotic agents that pose a very high individual risk of life-threatening disease, which may be transmitted via aerosols, and for which there is often no available vaccine or treatment. These are the most dangerous known pathogens, things like the Ebola virus or the Marburg virus.
So what does maximum containment look like?
It involves extreme precautions. Personnel must wear full-body, air-supplied positive pressure suits. They look like spacesuits. All work with the agent must be conducted either within these suits, inside a specially designed BSL-4 suit laboratory, or within a Class 3 biosafety cabinet located in a BSL-4 cabinet laboratory. These facilities are often separate buildings or completely isolated zones. They have dedicated supply and exhaust air systems with multiple levels of HEPA filtration. There are incredible rigorous decontamination procedures for absolutely everything exiting the lab, including personnel showering out and materials passing through sterilization chambers. And there's extensive training for staff, including emergency protocols. It's the ultimate level of biological containment, designed for absolute isolation of the deadliest pathogens.
That analogy of escalating security levels, like going from a kitchen to a fortress, really brings it to life. It's truly remarkable the amount of thought and engineering that goes into managing these invisible risks. Well, this has been a truly eye-opening deep dive into a field that, yeah, often operates behind closed doors, but really underpins so much of our daily lives and technological advancements. The key takeaways for us today seem really clear. The absolute critical need to recognize and properly manage biohazards, especially in areas like fermentation, and just the paramount importance of doing that thorough risk assessment and having robust biosafety measures in place at every single level. A huge heartfelt thank you to technologist Dr. Rama Yusvana from Tun Hussein on University Malaysia for joining us today. Your enlightenment and invaluable insights have truly deepened our understanding of these vital topics. We really appreciate your time.
It was absolutely my pleasure. Glad I could share this information and perspective.
So what does this all mean for you, our listener? Well, next time you hear about cutting-edge biotechnology, or even just enjoy everyday fermented products, think yogurt, cheese, maybe even medicines produced using these technologies, just take a moment to consider that invisible shield of biosafety working tirelessly behind the scenes. It makes you wonder, what other hidden safety measures are absolutely crucial in fields we might take for granted every single day? That's definitely something to mull over until our next deep dive.